next up is Tom Guarr. Please join me in welcoming Tom to the stage. CEO of Jolt's Energy Storage Technologies. He's done a major rethink of reflow batteries for grid level storage. Welcome, Tom.
Thanks, John. Thank you. Thanks, John. As John mentioned, I'm Tom Guarr. I'm co-founder and CTO of Jolt, and we're making organic batteries for large-scale energy storage. This chart shows why we do what we do. The price of renewable energy, wind and especially solar, has dropped so dramatically over the last 10 years that it's actually now cheaper to generate electricity by renewables on average in the US than it is by coal or even natural gas. That's a dramatically new paradigm. However, it doesn't really tell the full story. And you've heard a little bit about that tonight. Renewables are not always there when you flip the switch. They need storage, and they need reliable, inexpensive storage. Right now, when we add in the cost of energy storage, the cost of renewables plus storage often exceeds that of a natural gas power plant like shown on the right hand of this slide. At Jolt, we're trying to reduce the cost of storage down to a level in order to reverse that equation. There are lots of options for utilities to store energy. Pumped hydro and compressed air are fantastic options if you have the right geography. Not always there. Batteries are more widely applicable, but lithium ion, shown on the bottom left, tends to be a little bit expensive. What renewables actually need is a very inexpensive battery that will last for 20 years or more. One option is called a flow battery, and it's shown on the right. Flow battery works in the same way as your car, where you have active materials held in an external fuel tank. It's pumped through a central engine, which develops power. In the case of your car, gasoline is used to produce mechanical power. In the case of the battery, we use a combination in a flow battery, combination of a negative electrolyte and a positive electrolyte, or fuel, is used to generate electrical power. So the most common type of flow battery is called a vanadium battery. We don't need to go into technical details. I just want you to take away two messages about vanadium. First is that both the positive and negative fuels in a vanadium battery are really expensive. And what Jolt has done is replace those with a very inexpensive organic compound, and it's actually a material that can be used as the active component in both the positive and negative fuels. Second thing about the vanadium battery is it requires a very pricey ion exchange membrane in the center of the device, and this can account for 30 to 40% of the total cost of this cell. Jolt chemistry allows us to replace that $800 to $1,000 per square meter membrane with a simple $5 per meter porous separator. The net result is that we get 4 times the energy storage at a quarter of the cost. If we compare the attributes of the different batteries that I mentioned, lithium ion packs more power per pound than any of them, and it's a clear winner for mobile applications. Where cost is more important than weight, now the equation is a little bit different. And you can see in capital costs, Jolt is significantly lower in cost than lithium ion or vanadium, and that difference is even more pronounced when we consider levelized costs over time, because the lifetime of the Jolt battery is predicted to be about twice that of lithium ion. Stationary energy storage is a rapidly growing market, and flow batteries are predicted to gain an increasing market share in this growing market. In fact, the most conservative estimate that I could find puts the CAGR at 25% and a $9 billion market for flow batteries by 2028. Jolt was launched with a very simple and crazy idea that we could make a better battery. And we spent our early on, we focused on developing the chemistry in the lab and developing an IP portfolio. We received some seed funding, which allowed us to refine the technology, but our progress has really accelerated when we joined CRI. We've been able to perform some critical testing, refine our technology even further, and begin to scale up. Next year, we hope to have a larger prototype in the field for field testing. We've already secured a commitment from a partner to offer a pilot site and to help us take data. Jolt was started by my co-founder, Jack Johnson, and myself. Jack is a former chief engineer at JCI and was responsible for building their lithium-ion battery manufacturing plant. He's also a co-founder of Volta Power Systems. I was a VP at Gentex Corporation. I have a number of patents in the area of electrochemical devices, one of which is a commercial device that you probably have in your car. Stop by the booth and I'll tell you a little bit more about it. We've also added Scott Lindeman as an advisor, help us in customer acquisition and in financial matters. We're seeking introductions to advisors in the utility or energy storage industries. We're also looking for potential manufacturing partners and future investors because we're seeking a $2 to $3 million round next year, late next year. So in short, we're Jolt Energy. We offer 4 times the energy at a quarter of the cost, and we have the experienced team to pull it off. Thank you.
Good, sir.